In the last video, we looked at the theory part of momentum, and in this video, we'll look at impulse. But before we go to impulse, let's dive into how to use the formula for momentum. Let's look at this example. So, it says a cricket ball of mass 160 grams is bowled at 40 meters per second towards a batsman. Calculate the momentum of the cricket ball. We know that the formula for momentum is P equals to M multiplied by V. Let me put some arrows there to show that these are vectors. So, I usually tell my students that they should always write what they are given. And what am I given? The mass. What is my mass? 160 grams. Okay, but we cannot use 160 grams because we say that the mass should always be in kilograms. So we must change these grams into kilograms. And how do we do that? We divide by 1,000. And this is going to give us 0.16 kilograms. And then, now, what else are we given? We are given the velocity. And what is my velocity? 40 meters per second. So now we take whatever that we are given and substitute into our formula. So our momentum is going to be, what is our mass? 0.16 multiplied by, what is our velocity? 40. Okay? Then our momentum is going to be 0.16 multiplied by 40, which is going to give us 6.4 kilograms meters per second. But now we say that momentum is a vector, and a vector is a quantity with both magnitude and direction. We have the magnitude now, we need the direction. Where do we get our direction? I go back to my question. A cricket ball of mass 160 grams is bowled at 40 meters per second towards a batsman. So the initial direction was what? Towards a batsman. And there was no change in direction of the velocity. So our momentum is going to be 6.4 kilograms meters per second towards, okay, this is supposed to be towards the batsman. And that's your answer. So this is how you apply the formula for momentum. So let's try another example. Let me just erase this. Let me just erase this. Let's try another example. Let's say you have object A and object B. Object A has a mass of 100 kilograms and a velocity of 12 meters per second. And object B has a mass of 80 kg and a velocity of 15 meters per second east. And also this one for A is east. These are the directions. So now, which object between the two will be the most difficult to stop? You can pause the video and try to do this on your own and see if you get we get the same answers. Now, let's look at it. We have object A, which has the mass of 100 kilograms, velocity of 12 meters per second in the direction of east. We have object B with a mass of 80 kilograms, a velocity of 15 meters per second, and it's also going to the east. So we want to know which object is the most difficult to stop. Now, let us look at their momentums. The momentum for A, just put A, equals to the mass multiplied by the velocity. The mass of A multiplied by the velocity of A. What is our mass for object A? It's 100 multiplied. What is the velocity? 12. And what do we get here? We're going to get 1,200 kilograms meters per second east, because there was no change in direction. Okay, let's look at the momentum for object B. We're going to have P, which is our momentum for object B, equals to the mass multiplied by the velocity of object B. And then what is our mass? It's 80 multiplied by, what is our velocity? 15. And then we get, this will give us 1,200 kilograms meters per second east. Okay, so now since their momentums are the same, what do we say? What do we say? We're going to say they are equally difficult to stop. Why is that? Because their momentum, they are the same. Their momentum, they have the same momentum. The momentum of A, of object A, is equal to the momentum of object B. I hope you understand. So we're going to move on to the next topic, which is the impulse.